Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Find the values of C such that the second pivot becomes 0, and the values such that the third pivot becomes 0 for the given matrix A. The pivots are the diagonal entries we rely on during elimination. If one of them is 0, at the moment we need it, elimination either requires a row exchange or it can fail completely. We'll do elimination in stages and watch how each pivot depends on C. The first pivot is 1, so elimination can start for every value of C. These multipliers tell us how much of row 1 to subtract from rows 2 and 3 to clear out the first column. Row 2 changes, and the would-be second pivot becomes the expression 4 minus 2C. Row 3 now has 5 minus 3C in the second column. This matters if we need to swap rows later. After step 1, we're ready to inspect pivot 2 at position 2, 2. Without any row exchanges, the second pivot is exactly P2 equals 4 minus 2C. Setting the second pivot to 0 gives C equals 2. So at C equals 2, elimination hits a 0 pivot in the second step, which blocks an LU factorization if we refuse to swap rows. But we can check whether the entry underneath is non-zero. If it is, swapping rows can rescue the step. Since -1 is not 0, a swap puts a non-zero entry into the pivot spot, so elimination can continue, but only with pivoting. That completes the first target. C equals 2 makes the second pivot 0. Next, we search for when pivot 3 becomes 0, assuming pivot 2 is usable, so we're in the case C not equal to. This multiplier clears out the 3, 2 entry using row 2. Apply elimination below the second pivot. We track only the new 3, 3 entry. That becomes the third pivot P3. Set the third pivot to 0 and solve. This gives C equals 1. Great. Pivot 2 is non-zero at C equals 1, so the algorithm truly reaches the third pivot and then fails there. Look at the matrix after the first elimination step when C equals 1. The last two rows match. Eliminating produces a 0 row, so there is no remaining row to supply a non-zero third pivot. This isn't a wrong row order problem. The matrix simply doesn't have 3 independent pivot rows, so row exchanges can't create a third pivot. 2 different pivot failures. C equals 2 blocks the second pivot unless you swap, while C equals 1 destroys the third pivot because the matrix loses rank. So the values are C equals 2 for a 0 second pivot, and C equals 1 for a 0 third pivot. Watch the next video to learn more. Next, we'll connect pivots to geometry, so you can predict these failures at a glance.